Hello everyone. Today we are doing the simulation for critical thickness finding. Critical thickness of insulation, which is very important to understand the physics of heat transfer, whether it is by convection dominant or conduction dominant. To understand that, we are having good parameter, that is critical thickness. So critical thickness, which defines the conductivity divided by convectivity of that particular rod. So for doing that analysis, I am selecting the workbench. So go to workbench, open the workbench. So it is steady state thermal. So click on the steady state thermal. After that, click on the engineering data. That engineering data, I said I have to define the insulation, which is the part of our study. So I will select, I will mention, I will add in the material list. So insulation, that property I can define here. So once it is defined, so I said it is one dimensional. So isotropic thermal conductivity I have to define. So I am giving isotropic thermal conductivity of 0.2. So it is material property already I have assigned. Now that I will give in the model part. So first I need to create the geometry. Select XY plane. Click on the sketch. Sketching. Draw the circle. The circle. Draw another circle with the dimensions for those circles. So radius I am giving, because radius of insulation I am taking. So outer radius minus inner radius, it defines the radius of thickness of insulation. So I am giving this as a R1 and this R2. So R2 minus R1 will be the thickness of this cylinder. So that we call as the thickness of insulation that we are going to find out what exactly with the where maximum heat transfer will be possible. So define this radius. I am changing this unit to mm. So go to unit, then millimeter. So I am saying this inner radius is of suppose 20 and outer radius is of 23. Okay, so this is the inner radius, outer radius I have defined. So I want to show it this R2 inside. So what you can do, go to the dimensions and there is a option move. So go to the move option and drag it inside. So this is R2 and this is R1. Once the geometry is done, we will go for the extrude. Once the sketch is done, then we can go for the extrude option. Click on the extrude, here available, extrude, select the sketch, apply, and then generate. Now at present, I not define the depth. So suppose I'm giving the depth of 400. So click on the change the depth and click on generate. So this is the solid domain I am having. As I said, it is having bare wire, and this bare wire is covering with this insulation. So this bare wire is a solid one, and over that solid again we are providing the insulation. It is also solid. So at present I want to understand only the physics of insulation. So I will not creating the geometry for the wire. Simply I am keeping as it is hollow section, and I will give the surface whatever the heat generated by the wire when there is a current flow. What is the heat generation possibility? I square R, current flow through the wire into resistance. So that, and I am assuming that heat will be generating the temperature, approximate temperature. Suppose I am saying 40 degrees Celsius. So the 40 degrees Celsius, the temperature I will give to this particular surface, inner surface. And after achieving that surface temperature of 40 degrees Celsius, that heat will transfer through this insulation by the mode of conduction. So that way we are trying to define the physics in this particular problem. So just go step by step. Once you start the simulation, you will understand what exactly we are going to do. So this is the solid geometry I am having. So geometry part is done. You can close this geometry part and directly move to the model. Now in the model, we have to define the material for that solid. Secondly, mesh. And thirdly, what exactly the boundary conditions and what exactly the results we are expecting from that simulation. So this is the model part. Once you have the model, first you have to assign the material. So there is a solid geometry. In that geometry is solid, move to the solid. And at present, the assigned material is structural steel. So I will change from structural to insulation, which we have defined the conductivity of 0.2. Okay, now mesh I have to define. At least if I am saying the mesh generate the mesh, you can see the mesh. Okay, but the physics will be more effectively defined in this through this thickness. So what I will do, I will go for the insert option and face meshing. Can you see the face meshing here? So go to the face meshing. Now this face I want to select, apply, and in that face meshing, number of divisions option is there. So I can divide these faces into number of sections. So I will say it is of 50 sections. Okay. Once you define this face mesh, now what I would need, I need more fine mesh in this zone. And it's some, you can see there is a bad quality mesh at this surface because thickness is defining along this radius. So I have to make it good mesh, quality mesh in this zone. For that I have two options. I will go for the insert option and sizing of these two edges. This one, acceleration, this edge and this edge, apply. Instead of giving element size, I am defining suppose number of divisions here 100 or 60 and then generate. You will see the change. This is a mesh. Okay. Now still there is a unmapped mesh and not good quality mesh. So I will go for the face meshing. For that I will go to the insert, meshing, face meshing and select the face, apply. And instead of that one, I am saying it is 5 or most step. Okay. Right. You can see the quality mesh in this zone. So still we are observing the aspect ratio. It is not good here. So I can go for the more fine mesh for the edge. So instead of I am defining suppose 100 here, I will try to reduce the element size by dividing the more number of divisions so that I can have good mesh because I am suspecting the aspect ratio criteria for this case. Now it is okay. So I can change the quality criteria. Here aspect ratio here. Okay, still we need some improvement. So I will go for the edge sizing and instead of here I will choose to 120. So we can say this, update the mesh. Aspect ratio is so once it is generating. Now you can see the mesh. Previously it was 6. Now it is 5. Again I will reduce the edge sizing. I will make it hard. Let's see what will be the change. Right click, update. Still it is same thing. I will change again edge sizing to 150. Let's see the changes again. No, see the sizing, it is okay, it is in the range. So I can go for the simulation next. But before that, I said I will define the parametric analysis. What should be the thickness of the radius so that it will be having more effect on the heat transfer, whether it is more dominant for the conduction or more dominant for the convections. That we can identify. How we can do? We can increase the radius, outer radius, and accordingly what will be the effect of on the heat transfer, that we can understand. For that, we have to go for the parametric analysis. To do that, there is one option, but again I have to close this one. Then I will open the design modeler, design geometry again. And in that already in the sketch I have defined this radius, right? So R1, R2 is the outer radius. You see Ri is the inner radius and O is the outer radius. So let's say R1, R2 is there. There was no parametric state, but once I click on this P parameter box, then automatically it will come to this parametric list. Now you see, if I'm clicking on the parameter, the name which we have given in the geometry same is reflecting in this particular part. So 20 we have given R1, internal diameter, outer diameter. So we have defined. Similarly, once we have defined this, generate, I'm closing it here. Go to the model again. So meshing is already done. So now next is define the boundary conditions. For defining the boundary conditions, what I said, we are giving the convection to this surface and temperature to this inner surface. So I'm giving a convection boundary condition to the outer surface because it is exposed to the atmosphere. So there is options, geometry selection. So select the surface first and then apply. And in this case, coefficient film, I am defining this as a 2 meter Kelvin. So again, I need to change the unit. It is watt per meter mm square degree Celsius. Instead of that, I will go for the meter. So it is 2 now. 2 watt per meter square Kelvin. So just let's check. Then once we have defined, we need to define the temperature. It is in the degree Celsius. I will change this unit to Kelvin. Now it is 300. I am assuming atmospheric temperature. And again, next boundary condition is temperature. So I am defining this temperature to this wall because it is the wire, and wire is connected with the insulation. So it will start transferring the heat from this hot wire to the insulation material. So I am defining this as a 340. So select this geometry, inner geometry, apply and generate. Now what is the output I am expecting? Insert. There is a probe option. So I am need the heat flux in this zone. So select the heat flux, select the surface black, and I need total heat flux. So the output is defined, input is defined. So this output I want to define as a outlet. So what I will do, I will select this part as a outlet parameter. So once I click on the parameter, you can see the change again. Output parameter we can observe in this case, right? P3, P4. So I am not selecting this one now, minimum, maximum value, or I am selecting this one. So again, it will be not appearing on the screen. So once I have this, I can go for the parameter analysis for different values. So it is of 3. So I will go for copy pasting, and I'm increasing this by 25, 27, 29, 51, 60, 35, 37, 39, 41, 42, 43, and 45. Now I need one more parameter, which is the thickness. So what is the thickness? For thickness, I will go for the expression. So it is T2 minus P1. P1. So it is defining another parameter, P4. So this is the parameter. You can say the difference of P2 minus P1. It is indicating the thickness of insulation. And still we are not starting the simulation. So once I click on this update option, solve option, it will start the simulation, and what it generated, maximum it was generated, it will update in this area. So let's start the simulation for this one. Solve. Wait for the completion, then we will see the graphs creation and all.